Hey everybody, this is Mr. Piercy, and what we're going to look at in this video is I'm going to show you guys some properties of a quadrilateral called a rhombus. So you will want some kind of a straight edge. You may want a compass depending on how you're going to be doing your constructions, and you may want to have a sheet of patty paper if you have it available to help you kind of compare some things of the figure itself. So what I'm going to do to construct a rhombus, I'm going to cheat a little bit. I'm going to use my ruler to construct a pair of parallel lines, and I'm going to kind of turn it the other way a little bit diagonally here, and then I'm going to just repeat the process. Okay, and so the quadrilateral specifically that I'm looking at here is A, B, C, and D. And let's just kind of darken it in a little bit so that way it's easy to see on the paper. So everything doesn't all look like pencil. So there's that. There. Okay. It's a little bit darker. That's okay. We can see what we're looking at. And now what I'm going to do is, if you have it, we want to use the patty paper. If you don't have patty paper, it's no big deal. You can, everything that we're going to be looking at here can be done without patty paper. It's just, this will be, I think, the most efficient way of showing you things. So all I'm going to do is just trace there we go. So we have A, B, C, D. Now, we constructed this intentionally so that it's a parallelogram. So a rhombus is a parallelogram, meaning that its opposite sides will be parallel to each other. The opposite sides must therefore be congruent to each other. The diagonals must bisect each other. The opposite angles must be congruent to each other. And the same side angles have to be supplementary to each other. And that's all true because we constructed it to be that way. And you can kind of just use the patty paper again. If I want to look at this angle here, BAD, if I want to just slide it down here so that vertex A and B are sitting on top of each other, you see, yeah, they make a straight line, so they are supplementary to each other. And if I if I turn it over and I compare the opposite angles, A and C, we can see that those are the same. Or if I, oops, turn it the other way, so that way angle D and B are sitting on top of each other, we can see that those are the same thing. So it does have all the characteristics of a parallelogram, but it has some special things about it, and that's what I want you guys to be able to see. Now again, if you don't have the patty paper, you can use your compass to do this. All we're going to do is we're going to compare segments. Now, because it's a parallelogram, the opposite sides, AB and DC, those have to be the same. Same thing with BC and AD, those have to be the same. And we can see that very easily on the patty paper. But if I turn, I'm going to turn my patty paper 180 degrees. I'm not flipping it over or anything, I'm just rotating it 180 degrees. And now on the patty paper, we're looking at AD, and we're comparing it to segment BC. And we can see that those are congruent to each other. And in fact, all four segments are congruent to each other. So one of the properties of a rhombus is that it must have not just two pairs of congruent sides, but all four sides must be congruent to each other. So that's one of the unique characteristics of a rhombus. Now, when we were talking about parallelograms, we identified that the diagonals will bisect each other. Okay, so I'm going to add my diagonals onto my original drawing, and I'm going to add the diagonals to my trace on the patty paper. And again, if you don't have patty paper, you can still do all this stuff, compare angle measurements and side lengths and whatnot with, okay, so here we go, with your compass and your protractor. And I'm going to label this point here E. So I'll put E here. Now again, because it is a parallelogram, the opposite or the diagonals bisect each other. So we can see AE and CE, those are the same. And we can see that BE and DE, those are the same. It's real easy to see with the patty paper. That's why I'm doing it. Now, one of the things that I want you to notice is that if I take the rhombus and I rotate it, like so, if I rotate it 90 degrees, we see that the diagonals, BD and AC, that they lie directly on top of each other. So that allows me to conclude that the diagonals are perpendicular to each other. And last thing that I want to kind of compare, so let's go ahead and write that down. We have perpendicular diagonals. And the last thing that I want to kind of look at is let's look at angle ABE and angle CBE. All right, so I'm going to take my patty paper and what I'm going to do is I'm going to flip it like so, so that vertex A is now at C and vice versa. C is at A, but B stays where it is. And what I'm looking at here are these angles, and I notice because the figure sits perfectly on top of itself that this angle here and this angle here are congruent to each other. Well, because of the fact that it's a parallelogram, opposite angles are congruent to each other, so this angle here and this angle here also have to be congruent to each other. So diagonal BD is bisecting the angles at the inside of the figure. And if I, well, is it true for the other way? So let's look at angle BCE and angle DCE. So now, starting here, all right, what we're going to do is, again, kind of flip it and compare it with the angles on the other side. So again, A and C are kind of at the same place now, and we can see that the figure maps directly onto itself. So that does show that this angle and this angle are the same, and because the opposite angles are congruent to each other, these two angles have to be the same also. So here we can also add that the diagonals are angle bisectors. So a rhombus has all the characteristics of a parallelogram, meaning that the opposite sides are parallel and congruent. The opposite angles are congruent, the same side angles are supplementary, and the diagonals bisect each other, but it also now has these additional characteristics, meaning that it is a parallelogram that has four congruent sides. If it's a rhombus, it will have diagonals that are perpendicular to each other, and the diagonals will act as angle bisectors to the interior angles of the parallelogram. And last thing, real quick about rhombuses, because the diagonals are perpendicular to each other, you notice essentially we're creating four congruent right triangles inside of the figure. And so because we have right triangles, that means any math that we've done associated with right triangles, specifically the Pythagorean theorem, trigonometry, and special right triangles, may still be used with these figures. But that's it for the properties of a rhombus. If you have any questions, be sure